Hello, quick video on Mei C4 questions. This one's on 3D lines and using Scalar Product to solve problems. So here we go. Classic question here in front of you from 2007. So let's have a quick read of the question at the start. Verify that the point, and this is the point, lies on both of the lines. So here's line 1 and line 2, and then there's a second part. Find the acute angle between the lines. Okay, so first part is to verify. They use the word verify, so we can use the information they've given us, and we therefore just need to show that both this point here, the one is on the line. So we've got -1, 6, 5 is our point, and let's go with line 1. We know that it goes through the point 1, 2, -1, and it's got some multiple of the line vector -1, 2, 3. So I've written it like that. Okay, and my next step will be if I do the left-hand side, this bit here. I've got these two vectors, so effectively if I take one away from the other, I've got -2, 4 and 6, and that must equal some multiple of the line vector 1, 2, 3, and we can see that, can't we, that lambda equals 2, and all equations, all three equations, the x, y and the z, are satisfied. Yeah, so that one is on the line. You can see one vector is a multiple of the other. Let's go to the second equation quickly up here. 0, 6, 3. So here we're going to go. So here's the equation for line 2 on the right hand side, and here's our point P on the left hand side. So again, if I take away the position vector here, so I'm going to have -1, 0, 2 equals mu times our line vector 1, so that's +1 -2. So here we can see therefore that mu equals -1, and all equations satisfied. So again, in both these cases therefore intersects. Yeah, therefore points are on lines. Yeah, points are on lines. So that was fairly quick for the verification, wasn't it? Now let's have a look at the last part of the question. Find the acute angle between the lines. So here are two lines. If we want to know the angle between the lines, then we're interested in the angle between the line vectors always. Yeah. So we need to find that, and we can use our dot product to do this. So we're going to find the acute angle between these two lines. There's the line vectors here that I've written at the bottom. I'm going to rely on the fact that the dot scalar product A dot B is going to be the modulus of A times the modulus of B times the cosine of the angle between them. So here's our two vectors, and we're going to create the dot product, scalar product of those two. So we're going to have -1 plus 0 and a -6. So we've got a -7 as our dot product. Then we're going to find modulus of A, which is going to be the square root of 1 squared plus 2 squared plus 3 squared, which equals 1 plus 4 plus 9. So that's the square root of 14. And modulus of B is going to be 1 squared plus 0 squared plus 2 squared, which is 1 plus 4, which equals the square root of 5. Yeah. So therefore we know that the cosine of theta is going to be vector A scalar product with B over the modulus of A modulus of B. I've just rewritten the equation at the top. So I had minus 7 on the top, and then I've got square root of 14 times the square root of 5. And the thing we have to watch out for is I've got a negative cosine here. So I'm going to get an obtuse angle. So I need to sort that out in a sec. And if I go to my calculator, I'm going to find out I will get theta equals 146.8 degrees. That's an obtuse angle, isn't it? So I need to find my acute angle. And I'm going to do that because, of course, if that one is 146.8 degrees, then the angle I'm interested in is going to be 180 minus. So for my acute, I'm going to have 33.2 degrees acute, yeah? And here we go, that's 180 degrees. Minus 146.8, and you'll see that every time you see that we've got a negative cosine, we're going to get to that position. Okay, so in summary, one of these questions we can use the line equation. In this form, yeah, a vector line equation, a point on the line is a known point times a multiple of the line vector, and we can just substitute values in and find out what lambda is, or find a point by going the other way. Here's our scalar product, our dot product. We're just going to multiply the coefficients together. We can use that to find the angle between them. And in the most extreme circumstances you see occasionally, we can find the closest point between a line and a point, because the vector would have to be perpendicular to the line, and therefore the dot product would have to be 0. But that's the most complicated case. So hope that's of use.